Hello, hi everyone. Welcome to our webinar on cloud costs, their skyrocketing cost explosions, and the growth of AI. Let's just wait a few minutes for others to join before we start. I'm here, by the way, I'm Friso, and with me is my co host Eric, but we'll introduce ourselves in just a few minutes.
Good morning, everyone.
Morning, morning. At least when I look outside here in the Eindhoven offices of IO, it's a cloudy day, so that's
Ah,
right in theme.
when I look outside of the window here behind me, I only see hardworking colleagues. So,
Oh, well,
not,
okay.
but we do have a nice view here in Utrecht. So, at the camp,
Yeah, you do. I know. I know. I'm jealous of your view of the Dom Church always. That's quite impressive from the Utrecht office.
each campus has its own highlight.
Yeah. Okay. Well, I think we're 1 or 2 minutes past 10. We'll just uh, we'll just start, I think, and
Yeah,
just
good.
letting everyone know the webinar will be recorded, and questions can be asked after the webinar or in the chat. Let's kick it off. A session about cloud costs, skyrocketing cloud costs, the growth of AI, and most of all, also how to maintain control of your platform. Um, with me is my co-host Eric. Eric, your introduction slide is first, I think.
Yeah, that's true. Thank you. Yeah, so I'm Erik Post, working at IO Campus Utrecht in the role of technology director. So that means that I'm helping our clients with deciding on what platforms and what technology they can use best for yeah, achieving their goals. And that's also, I think, the main part of my job is making sure that technology helps you achieving your goals and not being the goal in itself. Your ambitions are your goal. 20 years plus experience mainly in DXP platforms and also cloud, and yeah, started as a developer a long time ago. So really deep technical background that still comes of use in many of the projects I do.
Absolutely.
So please, I think it's good you introduce yourself as well.
Yes, I'm Friso Geerlings. I'm technology director at IO Campus Eindhoven. Similar amount of years of experience to Eric, somewhat comparable role, but my focus is a little bit more on integration technology. And I always like to say, well, my focus is on getting things done in tech teams, and I believe in deliver often and deliver early. And yeah, happy to talk about cloud and AI with everyone today.
Uh,
Cool. A little bit of background about what we do at IO. This is just a short section, but first of all, I think it's important to realize, and I think everyone knows that, but there's always a gap, and that's also say in the field of AI, for example, there is the hype around AI in software development and how to actually do this in practice, how to embed AI into your software development lifecycle. Or we see impressive demos, but how do I actually deliver these types of projects? Well, for us at IO, it's about bridging this gap. And I think in the next slide, there's a little bit of background on our two key areas for this. Our key areas at IO for bridging the gap between vision and reality is around better customer experiences, more engagement, better personalization, higher customer value, etc. But also a strong focus on better operations. So how to streamline processes for speed, efficiency, and scalability. And well, I don't think it will surprise anyone that AI plays an important role in that. Today, we will be discussing cloud platforms in the broadest sense, But at IO, we also love our own AI platform, Bonsai, that actually integrates into the big cloud providers as one of the ways to automate our work and to bridge this gap. We do that at a wide number of organizations, from SMB plus to big enterprises. And I think it's mainly based on the fact that for many of the logos that you currently see on the screen, that we also develop platforms and help them to actually deliver platforms, that we have the right background, or at least experience, and we have had enough mistakes made and lessons learned to
Yeah.
tell you a bit about it today. So IO is with about 1,500 clients in Europe, and there are about 2,000 of us in the Netherlands, Belgium, the Nordics, 12 locations. We are speaking from Eindhoven and Utrecht today. Well, let's get started, I think. As I
Yeah.
said,
One more
QA.
housekeeping message. So any questions, drop them in the chat, and we will answer them afterwards. And we will share the recording of this webinar afterwards. So
Exactly. So what do you do as an AI-minded group of cloud specialists, in this case, Eric and me? You ask your AI platform, well, what are the most relevant cloud topics in 2026? And well, surprise to us, they were quite in line with what we together at a whiteboard already wrote down as the main topics. So cloud costs and FinOps is on the mind of everyone who is running platforms. That has a strong link to AI in the cloud, and also cost management and effectivity in the cloud, but also strategic hybrid cloud, how to approach cloud and how to approach sovereignty in the cloud. Those are really key topics for us. So I'd say let's dive into those. The first part is for you, Eric, and then I'll pick up
yes.
the sovereignty part.
Yeah, great. Thanks for the intro. Yeah, so as Friso mentioned, cloud cost and FinOps is of course relevant, has always been relevant since the explosion of cloud use, but it has become even more relevant with AI solutions and the use of AI tooling. But more on that later. So to start, I think it's good to explain a bit about what we call the cloud evolution model, because cloud didn't, of course, appear out of nowhere. It was like kind of a logical process from basically starting at on-premise. So where we had a traditional IT managed infrastructure, usually managed locally by our clients themselves or by other parties, which had the advantage, of course, of full control on hardware and software, but it also required a lot of capital expenses or upfront investments in order to buy the hardware, to buy the infrastructure, the networking, etc. And it also required a lot of internal maintenance and management. So all that old iron needed to be maintained. I think one of the most important disadvantages was the limited scalability. You always had to buy for what you would expect as peak usage, and that of course doesn't happen very often. So you basically oversize your hardware and you invest for things you aren't using all the time. So then we made the switch to infrastructure as a service, basically virtual compute resources, so CPU, memory, storage, which moved basically the physical hardware to like a virtual hardware managed by a cloud partner. And it still gave you quite a lot of control on how to configure and to manage your basically your computing resources that were physical before and were virtual with this move. And it also started the move to pay per use. So instead of paying upfront for buying a rack server, we started paying for actually the resources you were using. You could scale a lot easier by downsizing or upsizing your resources. We basically started providing more solutions for being scalable. Then we moved to what we call platform as a service. So where we have like a development platform that is offered by cloud services. So basically you build your application on top of the services that your cloud platform provides. So it's a bit of like more an abstraction away from compute resources, and more to, yeah, like things like serverless, where you, yeah, just build your application logic and the underlying platform manages everything around, yeah, how many storage do I need, what kind of processing power do I need. Yeah, and that really made the leap to being even more scalable, because it's very easy just to spin up a new function or a lambda in AWS, and yeah, scale from there. And then what we see now at the moment for a lot of solutions that our clients are using is, of course, software as a service, where uh, another party, an organization, provides complete functionality, software over the internet. And yeah, the party providing that functionality is also responsible for it. So they develop it, they maintain it, they extend it, they guarantee that it's scalable, that it complies to all the legislation that is relevant. Um, yeah, and that of course makes it very easy to use, and much less maintenance requirements. But of course, you're, yeah, depending on the functionality and the services that the SaaS service provider offers.
Yeah.
So yeah, what we see then is what we call shifting right. So going from on-prem, go low VPS kind of solutions to SaaS or even cloud native solution, and it has some kind of characteristics, not necessarily advantages or disadvantages, but yeah, ways things change. And one, of course, is that the time to market acceleration has been greatly improved, because yeah, you don't need long lead times for ordering hardware. You just enable or disable some services in your cloud, or you make sure that your SaaS provider handles that. So you're, yeah, you can yeah, deploy your solutions much quicker, and also provides more cost flexibility, where you, of course, first had to pay upfront and you didn't know exactly what kind of load you would get. So you, yeah, you always over provisioned and paid, yeah, too much for what you were actually using. And now you have way many more dials to turn in order to get the appropriate resourcing for your current load. And you're also, yeah, very much more flexible in handling those costs associated with those resources. But you also see that, like the centralized governance and standardization, that in the infrastructure as a service situation, you have a lot more control over what you're using, because it's yours. And uh, yeah, it's usually in a single data center or maybe two. And with SaaS and cloud native, you use a lot of different services that each have their own ways of making sure that they're conforming to guidelines and to legislation. So there's a bit more maintenance there, more effort to handle that in a good way. You also see that the cost predictability is also getting less, because yeah, that's inherently due to the way that costs are now based on usage and not on, yeah, what you pay up front. So it's very difficult in some cases to yeah, to know what the actual usage of your solution or your service will be. And if you don't provide some sufficient controls and ways to keep that in check, yeah, you can become for some very unpleasant surprises, where yeah, the bill is much higher than you would expect.
Yeah, it's also, I think, adding to that, Eric, sometimes quite a challenge for us at IO if you construct a platform for a client consisting of several SaaS components to make a somewhat reasonable upfront calculation. If you don't know the number of searches in Algolia, or it's hard to predict the number of logins per day, if someone really likes an app, what's it going to cost? That's
Uh,
hard. That's a hard problem.
yeah, with AI, it's even becoming harder, because there, but I'm already doing a sneak preview of what's coming later, is that it's with the token-based usage, it's getting harder to predict what the actual cost will be.
Yeah.
Yeah, so what we see is that you think, well, I'm in the cloud, I have everything in order, and everything is running fine, but then there's still some dark clouds that are gathering on top over you, and some topics that you really need to address in order to stay in control. And one of them is like, how do I enable my developers to make maximum use of the platform I provide? So I have like all these cloud services, which are very easy to turn on and to turn off. But how do I enable my development teams to make the maximum use of all those services without, yeah, reinventing the wheel each time? And the second one is that, yeah, because that cost predictability is getting worse. Yeah, how do I keep in control of my costs? How do I make sure that I don't spend too much, or that I get unpleasant surprises because there was some runaway service or something like that? And that's becoming even more relevant in with the use of AI this time. And then thirdly, and Friso is going to tell more about that, yeah, the world is changing. So the geopolitical situation is changing with the US and the dependency on big tech. So that's something that is yeah, really turning heads and really making people think about, yeah, what services am I using? What kind of organizations am I using those services of? And will that get me in trouble, or can I keep using that? So those are the three topics that we will dive a bit deeper in. First of the self-servicing developer. Um, yeah, so how do I enable my teams to make optimum use of the services my cloud provides? But before starting that topic, I think it's good to pay a bit of attention to what we call the shared responsibility model. And
Mhm.
what you see is that like each cloud provider has this written down or detailed, because it's very important to know what will my cloud provider do for me and where lies his responsibility, but what is my responsibility as a user of those services. Because basically, and if you look at the major cloud platforms, they divide it in a similar way. So in this case, it's an example from AWS. What they say is we are responsible for the security of the cloud. So we make sure that all the services that are in the cloud and that we offer, like all the hardware, so all the resources that those services are based on, that they are secure, so that we make sure that the software of like running the Lambda environment is secure, that our networking is secure, all those kind of elements, that's their responsibility. But everything you build on top of those services, so the thing you build in the cloud, that's the responsibility of the customer. And and sometimes you see that there's not a lot of clarity on who is responsible for what, and if there's then some kind of security incident, yeah, you have to look at the right party to know, yeah, where do I need to fix that, and was this something that could have been prevented? And as I said, this is the example of AWS, but Microsoft has a similar model on how they see security and responsibility in the cloud. And then if you look at like, so how traditional IT operations worked, then we had the development teams that they needed infrastructure to run the solutions, and that usually was a separate team, like an infrastructure or platform team that provided those resources. But the way that worked was usually by, yeah, creating tickets in a ticketing system like Jira or ServiceNow or those kind of platforms, um, and that resulted in long lead times because, yeah, the platform team had to pick up all those tickets and make sure that all those resources were created. Uh, they had to get approval for making those changes. So you see that the dependency on such a central team, yeah, it requires more alignment. So you have to do more conversations with each other to make sure that everyone is doing the right thing. And usually also that team is a limiting factor because yeah, it has a set capacity that doesn't scale very quickly. So yeah, you're bounded by like the capacity of that platform team. Yeah, and you also see, and it depends a bit on the organization, but you sometimes see like an us versus them mentality.
Mhm.
So we yeah, we throw it over the fence, so to say, and we let the other team handle it, and the other team, they will, yeah, well, they ask this from us, but that's not it doesn't make sense or it's not realistic. So there's limited ownership of what is needed to actually build your solution. So yeah, one of the things we see that worked well to address that is like introducing the capability of platform engineering. We still have like this internal development platform, but it's like a platform that provides teams ways to basically provision all the resources they need and to maintain them, and that the team can do that by themselves. So they don't have to ask another team to create like an app service or a container app in Azure. They get the tools and the means and the functionality to do that themselves. So that gives the development teams more autonomy because they don't have to request those services from a platform team. They can just create them themselves. So it moves from request away to like click and deploy. Just click a button and you have your service you need. But it also requires that you do a lot of standardization because you still have to make sure that all those resources those teams create that they comply to your security guidelines, that they comply to legal guidelines, like where is your data stored. They need to comply to the best practices and the standard architectures you have. So yeah, in one way it enhances that, so it makes sure that everything is more standardized, but it also requires that you have those standards in place. And if you have that, yeah, then the teams can become more accelerated because they don't have to reinvent the wheel. They can use what's already there, and they don't have dependency on a central team that they actually need to provision the resources. So the role of that like platform teams also shifts from like the operational team in creating all the resources, more like in creating all the tooling around it and making sure that all those best practices and that standardization is like implemented in the process and available for all the teams. So, and the interesting thing is that you see that your platform provides a certain amount of flexibility that moves from quite rigid to uh, uh, very much flexibility, but that also influences the execution power. So how easy can the teams create their resources, create their solutions? And what you see is that like that's just it's like a bell curve where there's some kind of optimal place where you have the most execution power while providing enough flexibility. And of course, this is like kind of an abstracted diagram showing this. But the interesting thing and the point I wanted to make here is that that curve is changing because now with AI, we move into the era of what we call then AI-powered platform engineering, where you can use AI tooling to even improve that standardization, to make tasks easier, to do analysis of issues, all those kind of things. So, yeah, applying those AI tools to your platform will increase your execution power.
It's always also a great way to really apply best practices, right? Because you
Yeah,
see that there's a lot of investment from the big cloud providers on making sure that their AI tools are based on best practices and well
yeah.
architected principles.
Yeah, and you see a lot of that in the documentation, like for example, Microsoft, but also AWS says that they have really written down all like the security best practices and how you
Yeah,
should configure each services in such a way that it's secure and that can be used in a good way. Yeah, yeah. So to show where like where AI is relevant or could be applied to platform engineering. So this diagram it shows like the capabilities that you usually see in a digital platform and then maintained by the platform team. So things like service discovery to know what services are available, what APIs are available. There's things like the continuous integration, continuous deployment pipelines, of course, your cost management. So there are a couple of capabilities that you usually see in such a platform, and which allow the streamlined teams to develop their solutions. And there are a lot of places where you, of course, can add AI to make things easier. So monitoring and observability, for example. Yeah, you can use assistants and agents to analyze all the data that is coming in from your monitoring solution or your observability solution, and do analysis on the data to identify issues or to identify hotspots where the developers can look. You can apply it to data and knowledge, and make sure that documentation is accessible in like a chat GPT kind of environment or Copilot or in Bonsai. Um, you can also provide foundational models. So it's not only about applying AI in like your platform team services, but also providing the service to build AI solutions. So yeah, making sure that teams have access to appropriate models, that the data that is sent to those models is handled in a good way and stays within the EU, for example. Yeah, so there are a lot of areas where AI can be applied to yeah, make work easier or more efficient.
Yeah.
And yeah, the interesting thing is then how do you enforce like that all your patterns and guidelines and so on are applied? And I think you can divide it in like three moments in time where that happens. So you have generation time where you use AI tooling, for example, to create your infrastructure as code scripts, or make the configuration settings. And those are usually done by using good instructions, prompts, using skills for Cloud Code, for example, and making sure that your documentation, your body of knowledge is readily available for yeah, to provide the right context. And then, of course, like in infrastructure as code tooling, there also is always a plan time where you yeah, look at what state you want to have for your environment and compare that to the actual state, so that the tooling know what changes can be made. And there are also tools like Terraform linting and Sentinel that can do checks on the generated infrastructure scripts to make sure that they apply to comply to your standards. And then at runtime, there's a lot of services available like Azure Policy or AWS SCPs that audit the actual resources being created or updated, and then either approve or deny those changes. And so there's like the three levels where you can make sure that yeah, the output your AI tooling generates conforms to the standards and guidelines that you use. And coming back to like where we started with the shared responsibility model, yeah, what you see is that the cloud providers extend that responsibility model to the use of AI as well. So this is an example from Microsoft, where they clearly state what lies with Microsoft, what lies with the customer using it, so that there's a clear distinction of what party is responsible for what part of the solution. So that's interesting to also look this up for like AWS if you're on it, or GCP or any other cloud platform.
Yeah, absolutely. I'd really like to emphasize how important it is to really understand this for AI platforms, because especially in multi-agent AI solutions that are now gaining a bit of traction, it's important to understand this well. Yeah.
Yeah, agree. Yeah. And already touched a bit on like the knowledge, so your best practices, your standard architecture, and I really want to emphasize that because in AI, context is king. So the quality of your context determines the quality of your output. So it's really important to invest in making sure that all that knowledge is externalized somehow. So either in documentation or markdown files, or yeah, your best practices that are written down, your ways of working. Yeah, if you don't have that, yeah, then you're not as effective as you can be. So it's really important to invest in writing that down and making sure it's up to date. And AI can also help you with that, because you can very easily use an assistant to create documentation based on code, and or keep it updated if it's already there, or based on user stories and so on. So there's a lot of possibilities of doing that in an efficient way. Yeah, and then moving on to cloud cost control. So what we see is that, and this is already a bit from 1 or 2 years ago, from last year. So numbers have probably changed a bit, but it's good to give an idea on what we're talking about. So there's a lot of waste in cloud usage. So a lot of
Mm.
resources, services that are running, but nobody's using them. And so last year, that was like 27% of cloud cost was waste. So there's a lot of opportunity to improve in that area. And but the question is then, how do you do that? So this is a model that we often use for that. So it starts with giving teams visibility on the cloud spend,
Yeah.
on the cloud cost. So yeah, if they don't know what their solutions are costing, they can't act upon it and they can't improve it. So you need to provide dashboarding or alerting or reporting to make sure that teams know what their solutions are costing. And then the second step is basically, yeah, also giving them responsibility for their cloud costs. Because if you give them responsibility, then they can act upon it and they can make the changes to, yeah, to optimize the costs or to yeah, upfront think about what their solutions will cost. So you need to give them the means to influence those costs. So to make choices in order to use a different service or to scale down a bit or all those kinds of things. And once they have the responsibility, they can do the optimization. So they can, yeah, really think about what can we do to improve cost, can we reduce it. And yeah, one pragmatic example of how you could do that is just included in the sprint review. So in the sprint review, take a couple of minutes to look at, yeah, what did we have as costs for the last sprint or the last two sprints, and do we see any opportunities for optimizing there? And the second one is to, yeah, make it part of the definition of done. So it's not only look at like the functional and the technical requirements, but also look at, yeah, if we build it this way, what will that do for the costs we're having for our solution?
Yeah, I'm sometimes even a bit surprised that we have so much focus on keeping our solutions secure, for example, but that we don't really look often, or at least I see it with many clients, on managing the cloud cost side.
Yeah,
So it's just a very important part.
yeah,
Yeah.
agree. Yeah, so to expand on that, couple of best practices that we see that you can apply in many cases is, as I mentioned, the visibility and usage awareness.
Yeah.
So that's really the basis to start from. So if you don't have that yet, then there's not a lot of opportunity to actually optimize. So really start with getting that visibility with the reporting and the alerting. Then you can also do guardrails, and I think some people will disagree with this, but I think it's important to do to make sure that you don't get runaway costs,
Mm.
because usually you don't want to limit your teams too much on what they can do. So, like if you set like budget limits, that can be a very good tool to make sure you don't get any excess. Uh, but you would still need to provide sufficient room to allow the teams to experiment and to make choices that will help them do the right thing. But you would need some guardrails to make sure it doesn't get out of hand. And it's also important to, yeah, keep re-evaluating how your solution is being used, because what we see is that it's often designed for, like, we go live with it for the first time, and there's not always a lot of attention in how the workloads change and how the patterns of usage change. And that's also something that you would periodically need to look at to make sure that all your sizing of your resources actually matches what is needed. And often that is done on the way to scale up, like we see we don't have enough capacity, uh, but it's not always done downwards, where we see that usage is declining, let's scale down a bit. And of course there are like a lot of options to do that automatically, but not all resources support that. So yeah, it's something to really take a look at.
Yeah.
Yeah, and also cloud cost control is something that you need to do all the time, not just once or each half year or something like that. You would really need to integrate it like your iterative process, like in the sprint reviews or other moments where you take a look at how are we doing cost wise and where are the opportunities to improve. Yeah, and basically the simple thing is that for AI, it's not really that much different. It's only more getting more important because with AI we have entered the token-based economy where usage is of costs are basically determined by how many tokens you use. But a token is quite an intangible, uh, difficult thing to predict. And on top of that, yeah, LLMs are not always deterministic, so they do not always generate the same results. So yeah, the costs of your output are also not always the same. And also, when you add more context, yeah, that context is also converted to tokens. So yeah, more tokens is more cost. So here basically the same principles apply. So visibility, make sure that you see how much you're spending. Give responsibility to the users, to the teams using the tools, and try to optimize. So don't always use the most expensive model for certain tasks. If you have like text analysis, yeah, a cheaper model can usually give pretty good results, and you don't need the most expensive, newest model to do that.
Yeah.
And also like summarize your conversations and be smarter in how you handle the context. So there are a lot of tools that you can use to optimize that. And the issue we're seeing is that like in cloud, the tools for getting visibility on those costs, they're quite developed. There are open standards on how to exchange cost information. Yeah, but the AI tooling is not that far yet. So there are a lot of different tools, not a lot of easy ways to get access to the cost. So and that's something we see with our own bonsai platform as well. So yeah, in the last couple of weeks, we spent a lot of effort to making sure that everybody can see what they're spending when they use our own AI platform to give that visibility. Um, so
Yeah,
yeah,
absolutely. Absolutely.
so that's about like the self-serving servicing developer and cost control. So let's move on to
Yes.
the topic.
The final ingredient of the cloud mix. So we know how to allow all those cool tools to be used by development teams, and we have cost control managed. And the platforms that do all of that in the best way are, well, all American platforms. So let's have a little bit of a look at geopolitics that are involved in this. I think, well, until early 2025, I think we can all be honest. The key trend really was just move to hyperscale cloud services because they allow you, as also Eric mentioned, focus on your business, not on servers. You could use their super innovation power to grow along with the Azure's, AWS's, Salesforce's, or super CMS's. Um, yeah, you could scale your OPEX smoothly and linearly with a growing user base and yeah, build easily one-click available, stable, well-documented technology platforms. That's the key thing that they really do deliver. Let's be honest about that. And yeah, well, maybe just as important is you get security levels that are really hard to do well by yourself. And I think this is often underestimated how much effort big cloud providers actually put in the security of the cloud, as Eric mentioned in the shared responsibility model. You can still screw things up in the cloud, but at least you know with these big providers that the security of the cloud is in order. But yeah, in short, this means that we were all shifting right in the cloud evolution model. But yeah, then this happened, and I think the first picture of this news flash is already on screen. We had American influence on big tech, right? The US imposing sanctions on the International Criminal Court, quite a bit of a shock. But much more things were happening. The big tech providers all made a deal with Trump, and suddenly their political alignment changed quite a bit. And yeah, we saw all of these types of things happening, right? Do US authorities have far reaching access to European cloud data? Well, you tell me. It seems to be the case based on the different laws and regulations that are in place. So we have to look at what this means for our platforms and what we should do with it. Um, I really like to illustrate this a little bit based on a typical case that I myself saw at IO Campus Eindhoven. We built a new platform for the Dutch Department of Social Affairs, typical government project. It's used to apply for company grants in the Netherlands. And the ministry, well, yeah, they were actually maybe a little bit ahead of the curve and thought like, okay, we have to run this on Kubernetes and we will go to that nice Dutch company Solvinity because it's not a US cloud. But then I think one of the things kick in here that is good to keep in mind, Kubernetes and not running on the right shifted serverless cloud brings complexity because we had to invest about 1,250 hours to bring everything live on a super complex database, Kubernetes, non-US tech cloud. And yeah, then in 2025, in November, we got the big news that I think everyone who is in this webinar also knows about. Solvinity was to be acquired by Kyndryl. It would become an American company as well. So yeah, that was also widely in the news in this situation. As you see here, a lot of unrest at governments. What do we have to do? Will DigiDay become American, etc., etc. I think it's just good to scroll through some of the panic here that was actually happening. And well, it brought us to the conclusion that maybe we should lean less on US tech, but what does this mean? And my own platforms, are they non-US hosted if companies can be bought? Well, that's a hard and difficult question. In December 2025, we discussed this about the platform. Should we move away from Solvinity? But as in typical complex, not easy to shift platforms, we decided, or the ministry decided, let's keep it at Solvinity. So it will probably be under US influence, another platform, Dutch platform like DigiDay. And actually in May this year, so just a few days ago, this was once again also confirmed for DigiDay. It will stay at Solvinity. A lot of effort was put into moving it there. Yes, maybe in the future, these Dutch government platforms will be moved over to another cloud or a European provider. But so far, it's not a realistic option. But let's look at the options you do actually have.
And this also, I think, illustrates how complex this problem is because basically the government decided to just keep it this way because it's apparently way too complex to move away and to get it under complete Dutch control. So
yeah, and I understand that some political parties are critical about that, right? And say like, well, why didn't you move it over? But I think we as technology people also know that it's actually migrations are harder than new builds. So this is always tricky.
Yeah.
Good. Well, the four solution directions and their key characteristics. You could just, well, say, well, I'm just going to stay on that classic AWS, Azure or Google Compute Platform region. I get a super rich service catalog. Everything I want from the shift right trend is there. But I'm also completely locked into a US-based organization and their geopolitical effects. Probably this is a bad idea if you run a really strategic government or national service. But yeah, if you have a platform that's not involved in that, this could actually be something that you can definitely consider and do to just stay on here. There are also, however, from these providers, new offerings, the sovereign regions, and we're going to zoom in a little bit on that after this slide. But AWS, Azure, and Google Compute Platform now have so-called sovereign regions that they approach differently, but that at least aim to provide about 90% of the service catalog, and that have as they say, strongly reduced lock-in on a US-based organization. And this might make sense in specific cases, but the real legal independence is a little bit hard currently. There are not really any proven cases or trials in legal trials about what exactly this means, but they're a big trend currently. A lot
Yeah,
of
it's like a bit of unexplored territory.
yeah,
Territory,
it's
and
also fairly new. We'll see that
uh,
in the following slides.
and I think the cloud providers are also struggling a bit with how can we now, yeah, structure this in such a way that it's independent enough, but
Yeah, yeah,
still under control. So
yeah,
yeah, I think
exactly. Um, yeah, something that you hear a lot about is, well, just go to one of these European cloud providers like the Little Cloud or the Stackit Cloud and Co. And there are, of course, more and more popping up. But we should also be honest that currently, if you compare it to the big tech cloud providers, they have about 25% of the catalog available. Typical core services, there are container management platforms, load balancers, API gateways, but the more advanced or super scalable stuff is not yet there. But you have no direct US or China geopolitics, so that's a good thing. It's gaining traction, but it's lagging behind US and China clouds. But I don't think there are that many European companies hosting on Chinese clouds, so we can for now ignore them a bit, I think. And the last one is to look at the co-location services. They're sort of like the simpler version of the European clouds. E.g., Team Blue is big on this one, and you just get servers or container management or maybe managed databases. But yeah, it's usually limited to about 10 core services, and you have to do a lot of it yourself. And yeah, especially in the considerations block here, you have to check their ownership structure because you could have a solvency case going on there. But you also really have to invest in deep knowledge of these platforms, of backups, of recovery, of scaling, and of security. Because yeah, security of the cloud here is a lot of your own responsibility, and that's hard and difficult to do right.
yeah. So basically, you're seeing that for all these kind of solutions, you're basically shifting left again instead of shifting right. So
Yeah, including the need for spending a lot of efforts, knowledge, and money on doing things right that otherwise the big cloud providers would do for you. So it
yeah,
also just costs money. It
yeah.
costs money. Yeah. Well, let's have a little bit of a look on how the different big tech providers created a route to this sovereign cloud. So the second column that we saw on the previous slide. First of all, a little look at AWS because they are doing a lot of effort here. On the left side, we have, let's say, the American influenced AWS cloud or partition, as they now call it. And that also has data centers in Frankfurt or US East or Ireland, etc. That's where we currently run our AWS workloads, right? Well, what they did is on the right side, they introduced the AWS EU sovereign partition of the AWS cloud. And it's actually a completely new company owned by the same holding, yes, that are also creating data centers or regions or availability zones. And the first one opened in January of this year in Brandenburg, Deutschland. And yeah, it provides a really big service completeness. So this is actually a European company doing their accounting in euros with only European personnel touching your keys and separate DNS infrastructure. So in a way, you could say, well, it's just a different company even from the rest of AWS, but they are still owned by that holding. So I also kind of look at this like, okay, how different is this, for example, compared to Solvinity, who will be US owned? You still have that US owned aspects, but it happens with European companies all the time. I think that they are just being bought and consolidated. So that's a hard topic. An interesting aspect here is that there is a lot of legal analysis currently also being done at this setup and what it actually means if they were to split, for example. Maybe on to the next one. If you look at what Azure does, they also say, well, we have Azure EU sovereign regions, but they didn't build completely new data centers. They kind of like flagged racks in the Azure regions and encrypted them, and then handed the key management of that and the services around it to a European entity. So it's you could say, maybe harder to split off because it's part of completely US owned data centers. But still, the key management means that from a data security perspective, or looking at the data from a US perspective, it's better protected than running in one of the Azure regions that are in Europe, but that are fully under American control. So they have like a subset of the controls in place that the AWS sovereign regions have. And maybe a last one that is Google and how they do it, because they also took a different approach. Google is actually working with partner clouds. So they kind of like took their software pack, the Google Compute Platform Cloud, Git repo. I'd love to have a browse through that, what's all in there to scale it, etc. And they work with partners like Thales, Swatch, or T-Systems to actually install that Google Compute Platform API and management platform. And then, yeah, it's actually Thales who is running a Google Cloud for you. So it's in a way fully European. But not all services are there. So that's important to realize. It's a subset. So in the diagrams at the bottom of the slides, I kind of like gave an indication of the percentage of services that are there. In this case, it's about 30%, you could say, that's there.
And I think this one is interesting because basically the cloud services that Google provide are like kind of an API that you provide, and they leave it to other parties to implement that API. So I think that's an interesting direction that is also.
They promise to give implementation updates to these partners as well, but you never know what US pressure actually means, right? So
exactly.
Okay. Yep. Maybe just touching on some side topics. I expect some of you might think, well, what about Gaia X? We had a European super standard for cloud, right? And that is something that already originated in 2019, actually, an aim to be the Airbus of the cloud and specifications. And Gaia X is a Belgium non-profit with European government structures that was aiming to really create interoperability frameworks and standards for the cloud. With that, in essence, the idea is cool, is to have about 180 industry-specific spaces, like what would a healthcare cloud look like, or what would a financial services cloud look like, and how should it interoperate? But we sometimes see this with EU projects or EU mandated projects. This was super ambitious, but had actually quite unclear goals, or even core services. What's there? What's the core service for healthcare? What should it do? So Eurostack, for example, really wrote last year that it's still a path of bureaucratic inertia and misplaced priorities. It's probably true about Gaia X, is a bit painful, but I think we can for now safely ignore this one. AI, Eric rightfully touched on it quite a bit in his part. What about AI and big American providers? I think here we really have to be realistic. The American hyperscalers, they run their own chip designs on exceptional hardware. Even getting a number of big racks from NVIDIA puts you in a queue where Bezos and co have priority. They invest billions in development tooling for their platforms, and they have exclusive contracts with the LLM providers. And this means that in the box on the right, currently, at this point in time, all of the richest SOTA models or frontier models, SOTA stands for state of the art, that do text processing. Well, the real frontier is American and only available at American companies. And European AI providers are competent, but not competitive currently at this highest tier of LLM. But I think, as Eric also rightfully said, you don't always need a frontier model to do your things, but you sometimes do. There are some true European AI providers, and this is also something that we at I/O are now actively much more involved in, and also have the first client project starting. For example, of course, we have Mistral with their Le Platform offering. Skillway is a nice provider that has a model as a service and pay per token offering. And there's even GPT-NL, fully Dutch LLM. And yeah, in our AI platform at IO, we now also have private models that we run at Team Blue to do some really truly sovereign EU only offerings. Yeah, and using tooling like Light LLM helps. That's a distributor for LLMs. At least you can route your traffic around a bit. But here, yeah, as you see, there is a lot of US dependence, and we're not going to get rid of that easily. So what can I do now to limit US exposure? First of all, make sure that you should care, because this will be painful and you will lose functionality. So I think don't panic too much and think, am I a government service, or maybe I'm just a commercial service and I don't really care and I'm going to enjoy all of the benefits of shifting right. If you want to limit your exposure, buy or build Kubernetes expertise. That's an open source container platform, but it's much harder to do right than is often foreseen. At least Kubernetes gives you the option to shop between platforms with your application. And consider using more managed open source services at the hyperscalers compared to pure serverless. This is a bit against our shifting right principle, but yeah, if you want more flexibility, you have to take some pain, and it's probably better to, for example, in AWS, use a managed Postgres instead of their completely serverless Aurora offering, because I will at least have less of a vendor lock in here. Yeah, and also don't forget to check your dependence on SaaS products in your business, because yeah, you can, for your client platform, maybe be completely independent of US clouds, but if everything is in your Salesforce, you still have a lot of pain, because that's American run. And then maybe lastly, you can consider using some open abstraction frameworks for infrastructure as code, like Terraform that Eric mentioned, or SSD, compared to Bicep or CloudFormation, to gain a little bit more independence, but it's also comes at the price of having to build more knowledge. Yes, I think it's time for our key takeaways here. So wrapping up today, the cloud evolution model, shifting right. We really believe that this will continue to be a major trend, but as Eric said, put financial guardrails in place to continue investing in knowledge across teams, and building an AI context can definitely help you. The second one is a self-servicing developer. You need to drive cost consciousness and financial visibility deep in every technology team. But yeah, do this from day one, especially with AI, but then the self-servicing developer will be the way to go to build independence from swamped cloud teams. And lastly, geopolitics. Consider whether you work in or for a sector where this is a real concern, as there is a big effort involved to become truly independent. It's not easy. You lose a lot of benefits, but yeah, there are ways to do this, as we just showed. I think that's what we wanted to share today.
Yeah, I see one question in the chat from Owen. I think
Yes.
that's a question for you, Friso. So are all the same service types available in the EU sovereign clouds?
Yeah, it's a good question. So it's I put a little circle diagrams in the slides, but for example for the AWS EU sovereign cloud, it's about 90%. However, the missing 10% is relevant because, for example, you see that some of the biggest models on AWS Bedrock AI models are not in the sovereign region yet, and I think that's really just a matter of them not having enough GPUs to run those massive models. So the things that are missing are, a bit of unfortunate that they are missing. But I understood that the aim is to make sure that everything will be available eventually. Currently, not 100%. No. And you pay a bit more as well, by the way. It's a bit more expensive, the sovereign regions. I see other questions.
more additional question, I think it's already time as well. So we had till 11. So I think it's a good moment to wrap up.
Exactly.
Thank you everyone for joining, and hope you found it interesting. And if you want to know more, just drop us an email or contact us on LinkedIn, and we'll be happy to have a conversation.
Yes, and to reduce some of the panic around sovereignty
Yeah,
while still
absolutely.
staying realistic about that
Yeah.
end cost. Thanks a lot, everyone.
Thanks, everyone.